Hi everybody. So in this video, I'm going to show you how we can calculate conditional probabilities with Venn diagrams. We'll work through a couple of examples and then we'll try an exam style question. And if you want to work along with me, you can download this PDF from my website. I'll leave a link below. So in example 1, we've been given this Venn diagram and these probabilities. Part A, we need to work out the probability of y given x. Well, if we label our probabilities, we've got x intersecting with y. That'll be this overlap here. This will be 0.24. Then we've got the probability of x is 0.7. So this will be the 0.7 minus the 0.24. So this will have a probability of 0.46. And then this region, y but not x, will be the 0.63 minus the 0.24, which is 0.39. And we want to work out the probability of y given x. I showed you in the previous video the equation that helps us to calculate this. I'll quickly show you again. If we use the tree diagram, we've got x, probability of x, and then we have y. But this must be y given that we had x first. So we've got x and y. So the outcome will be x intersecting with y. And the probability of x intersecting with y is the probability of this one, x, multiplied by this one, probability of y given x. If I just take out that times because it's confusing, we can divide both sides by the probability of x. So we get the probability of y given x will be x intersecting with y over the probability of x. Okay? So that's just a quick recap of where this equation comes from. So we want to work out the probability of y given x. We'll have x intersecting with y. This is the 0.24 divided by the probability of x, which we're told is 0.7. So this will be 12 over 35. Okay? And then for part B, the probability of x given y. Well, we'll have x intersecting with y over the probability of y. So this will be the 0.24 divided by the 0.63. And this gives us 8 over 21. Okay? Let's try some exam style questions. So in example 2, we've been told to let A, B, and C be events, and we're given their probabilities. An element is selected at random from a union of events B and C. We need to find the probability that this element also belongs to A. So how do you think we could write this using the given symbol? Well, we want the probability of A given that B is in union with C. So this will be the probability of A intersecting with B in union with C. I'll put that in square brackets. Divided by, what term do you think this will be divided by? Probability of B in union with C. So this second term. So we want A intersecting with B in union with C. If we work this out separately, so A intersecting with B in union with C. Well, this will be we can have A and B, or we could have A and C. So A intersecting with B is a 0.13, or because it's union, A and C, and that would be the 0.12. And then for our denominator, the probability of B in union with C, when this will be B 0.13 or C, which is 0.3. So this will be 0.43. So if we go back to our question, A intersecting with B in union with C, this will be the 0.25 divided by the 0.43. And this will give us 25/43. Okay? Let's try one more question. So in example 3, do you want to give this question a go yourself? You can read through the question and then try and draw the Venn diagram and then attempt question B. It's really important that when you read these statements, you use the given symbol. You can pause the video, and when you come back, we'll go through the solution. Okay, so how did you get on with that? If we read the first statement, if he wakes up on time, the probability that he takes a bus is 0.6. So this is the probability of getting a bus given that he woke up on time. For our second statement, if he does not wake up on time, he takes a bus with a probability of 0.2. So this will be the probability of taking the bus given he did not wake up on time. And then the final one, the probability that he wakes up on time is 0.45. So a probability of W is 0.45. We need to find when they overlap. This will be the probability of B intersecting with W. And we can work this out because the probability of B given W will be B intersecting with W over probability of W. We know this value is 0.6. We want to work out B intersecting with W, and we've been given W as 0.45. So if we multiply both sides by the 0.45, we get the intersection of 0.27. And then we can work out this region, W intersecting with not B, because we know W adds up to 0.45. So this will be 0.45 take away the 0.27. This will give us 0.18. And then we need to work out this region, B intersecting with not W. And we can do that using this. This will be equal to B and not W over the probability of not W. Well, we're given this one as 0.2. We want to work out our numerator. And the probability of W is 0.45, then not W will be 0.55. So the intersection of B and not W will be the 0.2 times the 0.55. And this will give us 0.11. So we can label that on our diagram here. And then we can work out the probability on the outside by 1 take away each of them. And this will give us 0.44. For part B, What is the probability that Jordan wakes up on time given that he takes the bus? So if I just block this off, the probability that he wakes up on time given that he takes the bus. One, this will be W intersecting with B over the probability of B. W intersecting with B is 0.27. The probability of B will be the sum of 0.11 and 0.27, so 0.38. So the probability that he wakes up on time, given that he got the bus, was 27 over 38. Okay? Well, I hope you found that useful and that you've got a better idea on how to work with conditional probabilities and Venn diagrams. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.